In the last week, the mystery surrounding 3I Atlas has taken a turn no one saw coming. What scientists have just discovered about this massive interstellar object has left even seasoned astronomers speechless. And the data they've released may be the most important yet, because the element it's producing, the way it's moving, and the timing of what's about to happen, all of it suggests something we've never seen before. And as we're about to find out, there may be a reason for that. For months, telescopes around the world have tracked this Manhattan-sized object as it cuts across the solar system. But just days ago, new readings from some of the world's most advanced telescopes revealed something extraordinary. A metallic compound never before detected anywhere in nature, streaming from the object in steady bursts. It's a substance that until now has only ever been created through modern industrial processes here on Earth. At the same time, 3I Atlas appears to be shifting in ways no interstellar body ever has, slowing slightly, changing its alignment, and possibly locking into an orbit around our sun. It's behavior that defies physics and chemistry that shouldn't exist, all coming from an object that isn't supposed to be here at all. Some scientists are calling it the most significant interstellar event in history. Others aren't saying anything, because NASA and other agencies have yet to release the latest close-up images captured earlier this month. The silence has only fueled the speculation. Whatever this is, it's no ordinary comet. The gases it's releasing, the direction of its jet streams, the perfect stability of its path, they all point to something different. Something that challenges what we think we know about how matter behaves, and possibly how life travels through the stars. So if that sounds interesting, you'll want to stick around, because in this video, we'll go over everything you need to know. From the first sightings of 3I Atlas to the shocking discoveries of the last few days. And if you're here for the breaking updates and the newest data, then make sure to watch until the end, because that's where things get truly unbelievable. The story of 3I Atlas began on July 1st, when the Atlas telescope in Chile detected a faint object moving across the night sky. At first, it appeared to be nothing more than another piece of cosmic debris drifting through the solar system. But as astronomers began studying it more closely, they realized it was something entirely different. The object's orbit was not bound by the sun's gravity, and its path through space was unlike anything ever recorded. It was traveling too fast to belong here, moving on a hyperbolic trajectory that confirmed it was not from our solar system at all. It was passing through, visiting once before disappearing back into interstellar space. The object was soon named 3I Atlas, marking it as the third confirmed interstellar visitor ever detected, after Oumuamua in 2017 and Borisov in 2019. But from the very beginning, it stood apart from both. Early data revealed an unsettling coincidence. While it was supposed to come from another star system entirely, 3I Atlas happened to align almost perfectly with the ecliptic plane, the same flat, disc-shaped path that our planets orbit along. For an interstellar object, this kind of alignment is almost impossible by chance. It was as if something had guided it directly into the same plane that defines our solar system. When the James Webb Space Telescope and Hubble turned their lenses toward it, they found even more that did not make sense. 3I Atlas was active, venting gas and dust like a comet heating up near the sun, but it behaved in a way no comet ever had. Instead of ejecting a tail away from the sun, as solar radiation would normally cause, it produced a jet of material aimed directly toward it. Under normal physics, this should not be possible. The discovery sent shockwaves through the astronomy community, and even early on, scientists began to realize that nothing about this object fit into known models, and every natural explanation failed to reproduce its behavior. Unlike Oumuamua, which appeared solid and non-gaseous, or Borisov, which acted like a typical comet, 3I Atlas seemed to exist somewhere in between. It behaved like a comet, but moved with the precision and stability of something mechanical. Despite releasing hundreds of kilograms of gas every second, its trajectory did not change at all. Its orbit remained completely stable, showing no measurable non-gravitational acceleration, something that should be impossible for any object venting that much material. Normally, a comet's jets act like miniature thrusters, nudging it off course, but 3I Atlas held steady, as though locked in place by some unseen control. As more data came in, astronomers began estimating its size and mass, and that is when the mystery deepened further. Based on its brightness, 3I Atlas was estimated to be between 3 and 5 kilometers wide, roughly the size of Manhattan. Calculations suggested it weighed more than 30 billion tons, making it hundreds of times more massive than Borisov, and over 1 million times heavier than Oumuamua. For an interstellar object, that kind of mass was unprecedented. Its enormous size and stability meant that whatever it was made of, it was not fragile ice and dust like a comet. It was something far denser, something stronger. Scientists began to ask the obvious questions. How could it form naturally? Why was it so stable? Why was it behaving as if it were being guided? Some proposed that it might be a remnant from a long-dead star system, a fragment of a planet's core blasted into space eons ago. Others suggested it might have unusual chemistry, formed around a carbon-rich star unlike any in our region of the galaxy. But no matter what theory they tried, none could account for all of the data. The tail pointed in the wrong direction. The gases being released were in strange proportions, unlike any known comet. The object's perfect stability defied every law of orbital dynamics. As the weeks passed, more telescopes locked onto 3I Atlas, but every observation only deepened the confusion. The gases detected included carbon dioxide, cyanide, and nickel, an unusual mixture on its own, but what stood out most was the absence of iron. All comets we have ever studied contain nickel and iron in roughly equal amounts, yet this one showed no trace of iron at all. The question no one wanted to ask started to surface. What if it was not entirely natural? No one wanted to use the word artificial, but the possibility lingered. Here was a massive object, stable to the point of perfection, emitting controlled jets of gas, and showing chemical properties we had never seen in nature. Some scientists began quietly comparing it to a spacecraft, or at least to a relic of one, a piece of technology adrift in the void for millions or even billions of years. Others refused to entertain that idea, insisting there must be a natural explanation we had not yet discovered. But even they admitted, each time new data came in, that the mystery was growing harder to explain. By late July, the world's attention had turned toward it. Every night, observatories tracked its path, searching for some sign of irregular motion or rotation. None appeared. It did not spin. It did not drift. It did not behave like anything alive or dead. It simply moved forward in complete silence, following its path like it had always known where to go. And then, just days ago, everything changed. In the last few days, something extraordinary has started to happen. New orbital data from observatories around the world shows that 3I Atlas, the enormous interstellar object cutting through our solar system, isn't behaving like a visitor anymore. It's slowing down. Just slightly. Just enough to notice, but enough to matter. According to updated models released in late October, 3I Atlas may be doing something no interstellar object has ever done before. It might not be leaving. Every other object we've ever recorded from outside our solar system, Oumuamua, Borisov, and countless unconfirmed candidates, has followed the same simple rule. They come in fast, they swing past the sun, and they're gone forever. Their paths are hyperbolic, open, impossible for gravity to hold. But this one is different. If the new data is correct, 3I Atlas's trajectory is beginning to curve. It's as if something is slowing it just enough for the sun's gravity to take hold. For scientists, that's a once-in-a-lifetime event. If confirmed, it would make 3I Atlas the first interstellar body ever captured by our solar system, an object from another star, locked, at least temporarily, into orbit around our own. The change is subtle but unmistakable. The European Southern Observatory's tracking teams describe it as an unusual orbital evolution. Independent astronomers monitoring it in infrared have gone further, calling it a measurable deceleration, In plain terms, it's moving slower than it should be. The question is why? One theory is that the strange jets venting from the object are interacting with solar radiation in an unexpected way. The carbon dioxide and nickel gases it's releasing could be creating a kind of drag as they expand toward the sun. Combined with the sun's own pull, that might be enough to slightly reduce its speed. It's a natural explanation, but not a comfortable one, because it doesn't quite fit what we know about how gas behaves in space. The object's movement is perfectly timed with two major milestones. On October 21st, it passes directly behind the sun from Earth's point of view, entering what astronomers call solar conjunction. It will vanish for several days, hidden in the sun's glare. Then, on October 29th, it reaches perihelion, the closest point in its orbit to the sun. That's when the real test begins. If its speed drops below the critical escape velocity during that approach, 3I Atlas could become the first interstellar object to fall into a temporary solar orbit. That scenario isn't science fiction. It's basic physics taken to an extreme. But the odds of it happening naturally are vanishingly small. Harvard astrophysicist Avi Loeb has compared the object's current motion to an Oberth maneuver, a real technique used by spacecraft to gain energy by diving close to a star or planet and using its gravity for a boost. It's how NASA's probes like Voyager and Parker Solar Probe achieve their incredible speeds. For a natural object to follow a path that mirrors the exact conditions required for a gravity-assist slingshot is, in Loeb's words, peculiar. The alignment is almost too precise. The timing between its solar conjunction and perihelion is perfect, and the way its emissions line up with its orbital shift looks planned rather than random. It's possible that we're witnessing an incredible cosmic coincidence, one that happened entirely by chance. But it's also possible we're seeing something else, something no one expected. Even among cautious researchers, there's a sense of unease. No one wants to jump to conclusions, but the data doesn't lie. The object isn't behaving the way it should. If it really does fall into orbit, that means the first object we've ever confirmed from another star system won't just pass through ours. It will stay here, circling our sun, a silent relic from somewhere else entirely. For now, the only thing to do is wait. Over the next few weeks, every major telescope on Earth and in orbit will be trained on it. Once it emerges from behind the sun, we'll know whether it's gone forever or whether it's become a permanent part of our sky. And while its movement alone is enough to rewrite everything we thought we knew about interstellar physics, that's only half the story, because what 3I Atlas is made of might be even stranger than how it moves. In August 2025, scientists at the Keck 2 Observatory in Hawaii made a discovery that changed everything we thought we knew about 3I Atlas. Using high-resolution spectroscopy, they analyzed the light coming from the object's gas plumes and found something that defied all expectations. The readings showed that 3I Atlas was releasing about 4 grams of nickel every second. That alone would have been strange, but the real shock came from what was missing. There was no measurable iron in the emissions. Every comet ever studied, both in our solar system and beyond, has shown nickel and iron in roughly equal amounts. They form together during planetary formation, and the two elements are so chemically linked that finding one without the other is nearly impossible. But 3I Atlas had somehow broken that rule. It was giving off nickel in isolation, as if the iron had been filtered out. When the data was compared against known compounds, one match stood out: nickel tetracarbonyl. That name might not mean much to you, but what it represents will. Nickel tetracarbonyl is a refined metallic gas used in advanced manufacturing and aerospace engineering on Earth. It's produced through industrial chemical processes that separate and purify metals, creating coatings for jet turbines and high-performance alloys. It doesn't exist naturally in space. In fact, it doesn't exist anywhere in nature at all. On Earth, it only appears inside factories and laboratories. Harvard astrophysicist Avi Loeb put it bluntly when he reviewed the findings. He said, "This alloy has only ever been seen in human factories, never in a comet, never in space, never in nature." The discovery stunned the scientific community. If this gas was truly nickel tetracarbonyl, it meant one of two things. Either we were looking at a chemical process that had never been observed before, or we were seeing something that was made, not born. The publication The Debrief summed it up perfectly. If natural, it's chemistry we've never seen before. If artificial, it's evidence we weren't expecting. To understand how unusual this is, you have to picture what's happening. Imagine a massive interstellar object the size of Manhattan, venting metallic gas into space in short, consistent bursts. It's not random like a comet's usual plumes. The emissions come out in pulses, steady and focused, as if being regulated by something deep inside. That precision, combined with the purity of the nickel, suggests a process that doesn't happen on its own. Scientists have tried to find a natural explanation. One theory is that 3I Atlas formed around a carbon-rich, iron-poor star where the usual balance of metals might have been skewed. Another idea proposes that extreme oxidation stripped away the iron before the object left its home system. But both scenarios remain highly speculative. No known astronomical environment can create or sustain nickel tetracarbonyl naturally. Even if the right conditions existed, the compound is unstable. It breaks down easily in heat and sunlight, yet 3I Atlas is venting it continuously, close to the sun, without any sign of degradation. This isn't just an anomaly, it's a contradiction. The absence of iron implies that something refined the material, separating it from its natural pair. The chemical balance looks deliberate. The consistency of the gas emissions looks engineered. And the fact that this object is doing it while maintaining perfect stability adds another layer of impossibility. The implications are enormous. If 3I Atlas somehow formed this alloy on its own, it means we're witnessing a new kind of cosmic chemistry, one that challenges the limits of what natural processes can achieve. But if it didn't form it on its own, if this alloy was produced by some mechanism within the object itself, then 3I Atlas may not be purely natural. It could be a relic of something built long ago, or something that has been designed to behave this way. For now, no one can say for certain what's causing it. The data is clear, but the explanations aren't. The only thing everyone agrees on is that we've never seen anything like it. And as strange as its chemistry is, there's another piece of the puzzle that's even harder to explain, because it's not just what 3I Atlas is made of that's raising questions. It's where all that material is going. When scientists first noticed 3I Atlas venting gas, they expected to see something familiar. Every comet in history releases material that forms a tail stretching away from the sun, pushed by solar radiation and wind. But when Hubble and the James Webb Space Telescope began monitoring it in infrared and ultraviolet light, they saw something no one could explain. 3I Atlas was releasing a steady jet of gas directly toward the sun. Instead of being blown away from the heat, it was ejecting material into it. The plume was made of carbon dioxide, cyanide, and trace amounts of nickel gas, rising from its surface like steam from a vent, but traveling in the wrong direction. The debrief summarized it in one line. Rather than forming a tail like a normal comet, 3I Atlas emits a sunward plume of CO2, cyanide, and trace nickel. In other words, it's doing the exact opposite of what physics predicts. The amount of material it's losing is staggering. Observations suggest it's releasing around 330 pounds of gas every second, yet its orbit has not changed at all. That's impossible under normal circumstances. A comet losing that much mass in one direction should be pushed off course in the other, like a rocket adjusting its trajectory. But 3I Atlas doesn't drift. It stays perfectly stable. Scientists have proposed a few explanations. Some say it could be asymmetric heating, where one side of the object warms more than the other, forcing gas out unevenly. Others think it might be magnetically driven, with charged particles funneling material along invisible fields that bend toward the sun. But both ideas have problems. The venting has remained steady for months, not fluctuating with distance or rotation, and no magnetic model can explain its direction or precision. Avi Loeb described the phenomenon as intentional alignment, a term that made headlines. His point wasn't that it's artificial, but that it's too precise to be random. Every new dataset makes it look less like chaotic cometary venting and more like a controlled process, something designed to keep the object exactly where it needs to be. If that's true, then the venting isn't just a byproduct, it's part of its system. That level of precision brings us to the next question. How can something this active, venting this much gas, remain so perfectly stable? To answer that, scientists had to take a closer look at what might be holding it together. And the deeper they went, the more impossible it seemed. When astronomers calculated the mass of 3I Atlas, the numbers made no sense. More than 4,000 separate positional measurements from observatories around the world were compared, and each one confirmed the same result. Despite its heavy gas loss, the object's orbit has not changed. Its non-gravitational acceleration, the slight push that should come from jet activity, measures at 0. That means one of two things. Either 3I Atlas isn't venting as much material as it appears to be, or it's so incredibly massive that the venting has no effect. Based on its brightness and density, scientists believe the second option is true. The latest models estimate a diameter of around 5 kilometers and a total mass of over 33 billion tons. For perspective, that's roughly the same mass as Manhattan Island, and hundreds of times heavier than Borisov, the last interstellar comet we recorded. Under normal conditions, even the most stable comets experience a small but measurable drift when they release gas. It's a simple rule of motion. Every action creates an equal and opposite reaction. But 3I Atlas doesn't flinch. It moves as though anchored, ignoring the forces acting on it. Researchers have floated a few possibilities. The natural explanation is that it's made of something unusually dense, perhaps a solid metallic core, or a nickel-iron body from an ancient planetary system. But that still wouldn't explain its perfect stability. The more speculative idea is that it could be hollow, with internal balancing systems that absorb the momentum of the jets, keeping it centered. If that's the case, it wouldn't just be a rock, it would be a machine. Harvard's Richard Cloete summarized it in a single sentence. Either it's the heaviest comet ever, or it's something designed to resist drift. Whichever answer is true, it means 3I Atlas is rewriting everything we know about celestial mechanics. It behaves like a natural object, built with unnatural precision. And as this evidence began stacking up, one question started echoing across the scientific community. If all this data is real, if this object is unlike anything we've ever seen, then why haven't we been allowed to see it? Between October 4th and 7th, NASA's Mars Reconnaissance Orbiter captured the closest ever images of 3I Atlas from about 12 million miles away. The high-resolution shots should have offered the clearest look humanity has ever had at a confirmed interstellar visitor. Yet as of late October, those photos remain unseen. NASA officials have cited the ongoing government shutdown and limited staffing as the reason for the delay. In a brief statement to Space.com, a spokesperson said the data must undergo processing and verification before release. But outside the agency, that explanation hasn't convinced everyone. Astrophysicist Dr. Michelle Thaler, a former NASA science communicator, told CNN International that the lack of transparency was frustrating for both scientists and the public, adding that these are historic observations. There's no reason we shouldn't be seeing at least preliminary images by now. Planetary scientist Dr. Alan Stern, principal investigator for NASA's New Horizons mission, echoed the concern in a post on Scientific American's blog network. With an interstellar object this rare, he wrote, holding back raw data only fuels speculation and misinformation. Even researchers usually sympathetic to NASA's cautious approach have started to question the delay. A senior analyst at the European Space Agency told Reuters under condition of anonymity that each day, without imagery, increases public suspicion, describing the situation as a communications own goal. The speculation has quickly spilled online. Amateur astronomers and data sleuths argue that the missing images could reveal something unexpected, possible geometric shapes or metallic reflectivity inconsistent with a natural body. Some claim that internal telemetry hints at unnatural symmetry, though none of that has been confirmed. Historically, NASA has imposed temporary data embargoes when anomalies appear, citing the need for validation before public release. But in an era where space telescopes live stream galaxies in real time, that justification feels thin. As Space.com noted in an editorial, in an age of instant transparency, NASA's silence has created a void, and nature abhors a vacuum. On social media, the theories are multiplying. Some think the images show a fragment of an ancient probe, others a geological curiosity with mirror-like surfaces. Whatever the truth is, one fact remains. The most detailed photographs of the most mysterious object in recorded history are sitting on NASA's servers, unseen by the public. So what do scientists actually think this object is? Theories range from the extraordinary to the impossible, but no one can yet explain why 3I Atlas behaves the way it does. There are three main theories fighting for dominance right now, each trying to explain what 3I Atlas really is. They range from the grounded to the extraordinary, and together, they paint a picture of how divided the scientific world has become. The first theory is the one most scientists cling to because it's the least disruptive, the natural but exotic explanation. According to this idea, 3I Atlas is simply a comet from a chemically unusual star system. It could have formed near a carbon-rich, iron-poor star where the normal balance of metals was skewed from the start. That could explain the strange chemistry and the dominance of nickel in its emissions. The problem is that theory doesn't explain everything. It doesn't account for the refined nature of the alloy, the absence of iron, or the deliberate direction of its gas jets. Those features suggest something more organized than raw chemistry. Even supporters of the natural theory admit it's a weak fit for the data. It's the safe answer, but it doesn't satisfy anyone who's really looking at the numbers. The second theory goes further. It's known as the pre-solar artifact hypothesis, and it suggests that 3I Atlas isn't just from another star system, it might be from another era entirely. According to this idea, the object could be a relic from a planetary system that existed billions of years before our sun formed. It may have been drifting through interstellar space ever since, a survivor of cataclysmic events that destroyed its home system. Supporters of this theory point to its strange isotopic ratios and heavy metal content, which could indicate it's older than anything in our solar system. In this scenario, 3I Atlas would be a messenger from the deep past, carrying within it the chemistry of worlds that no longer exist. It's a romantic idea, less alien than ancient, but no less unsettling. The third theory is the one that's drawn the most attention and controversy: the technological origin hypothesis. This doesn't claim that 3I Atlas is a working spacecraft or that it's being controlled right now. Instead, it suggests that it could be a fragment of something engineered, a piece of debris, an ancient probe, or even the remains of a long-dead technological civilization. In other words, a machine, not a comet. This theory isn't coming from fringe voices either. Several astrophysicists, including members of Harvard's Galileo project, have openly said that the possibility should be studied scientifically, not dismissed. Their reasoning is simple. Every natural explanation so far has failed. If 3I Atlas is following a trajectory as precise as a spacecraft, venting an alloy found only in human industry, and possibly locking into orbit around the sun, then refusing to even consider an artificial origin is bad science. That's why the Galileo project has been quietly tracking 3I Atlas independently. Using ground-based telescopes and private satellite arrays, the team is collecting its own data in case the official channels go dark again. What they're looking for are signs of structure, symmetry, flat planes, reflective surfaces, anything that suggests intelligent design. And that's where NASA's unreleased high-rise images come in. If those photos show geometric patterns or metallic reflections, even by accident, the entire conversation changes. Adding to the unease is the silence from other agencies. Both ESA's JUICE mission and NASA's Juno probe will pass close enough to observe 3I Atlas, yet neither has confirmed whether they'll point their cameras toward it. The world's most advanced spacecraft are flying past a historic anomaly, and nobody seems interested in looking. Meanwhile, the public's patience is wearing thin. Every official statement calls it natural, a comet behaving oddly. But every new observation says otherwise. The object is too heavy, too stable, too precise. And the longer it stays silent, the louder the speculation grows. 3I Atlas has become the kind of story that lingers long after the data stops. A Manhattan-sized object venting metallic gas, holding a perfect orbit, possibly captured by the sun, its clearest images still locked away. Whether it's a cosmic anomaly or something more deliberate, the evidence points to a mystery too big to ignore. If it's natural, it overturns everything we thought we knew about comets, gravity, and interstellar chemistry. If it's not, it forces us to face an even larger question: who or what sent it here? 3I Atlas isn't just another visitor from deep space. It's a mirror showing us how much we still don't understand about the universe around us. Now it's your turn. What do you think 3I Atlas really is? A natural relic, an ancient probe, or a signal from something we've yet to comprehend? Share your theories in the comments below, and we'll feature the best in our next video when the missing NASA images finally surface. If you want to stay ahead of the mystery, make sure you're subscribed for more investigations into the strange, the ancient, and the unexplained. Until next time, stay curious.